So this video we're going to be doing areas of circles, sectors, and segments. Okay, so the area of a circle is pi r squared, where r is going to be your radius. Okay, so what is the area of the circular region on a wrestling mat? So this entire distance, so the diameter is 32, so we said it was A equals pi r squared, so A equals pi times the radius, so I need to cut this in half to get the radius, so 32 divided by 2 gets me 16, so 16 squared. So A equals, if we left it in terms of pi, it would be 256 pi feet squared. Remember, it's squared because we're still talking about area. Okay, so sorry this is really messy, but for some reason it deleted it. So definition of a sector of a circle: a region bounded by an arc of the circle and two radii to the arc's endpoints. So when we name these, we're going to say one endpoint, and then we're going to say the center of our circle and then our other endpoint. Okay? To find the area, we're going to take the arc measure, so the measurement of the arc, divided by 360 times pi times whatever our radius would then be. Okay, so if we said sector, it'd be sector RPS or SPR. Okay, so you always start with your endpoint, then you do your center, and then your other endpoint. Okay, find the area of the sector. So we said it's our arc measure. So arc measure divided by 360 times pi times your radius. So our arc measure is 72 times pi times our radius, which is 15. We're going to leave it in terms of pi. So I'm going to take 72 divided by 360, and I get 0.2. That's a pi. Times 15. So 0.2 times 15 now. So it's going to be 3 pi centimeters squared. Okay, because we're still finding area. Okay, the segment of a circle, so a region bounded by an arc and the segment joining its endpoints. So it's an arc, and then it's joined by two endpoints. So here is my segment, okay? So we're doing the area of the sector, subtracted from the area of the triangle to find the area of the segment, okay? Or this equation here. So our arc measure divided by 360 times pi r squared minus the area of that triangle, okay? So this was this, which we found in the last problem, minus the area of that triangle to get the area of the segment we want. Okay, because if you notice this little triangle, if we subtract this out of it, what do I have left? The area of that segment that we want in the circle. Okay, so the area of the entire sector, we do the arc measure divided by 360 times pi times r. So our arc measure here, if this is a square, that means that's 90 degrees, so my arc measure should equal that. So we got 90 divided by 360 times pi times our radius that's given, so 4. So 90 divided by 360, we got 0.25. We multiply that times 4, so we have 1 pi meters squared. Okay, now let's find the area of that triangle. So if we have this radius being 4, then this radius is also 4. Okay, so the area of a triangle is 1/2 times the base, which is 4, times the height of that triangle, which is 4. So 4 times 4 is 16. 16 divided by 2, we have 8 meters squared. So now we subtract them. So 1 pi minus 8. Okay, so I am going to take pi minus 8 in my calculator. I messed up. This was supposed to be squared, sorry. So it's going to be 90 divided by 360, which is at 0.25, times 4 squared, which is 16. So that's supposed to be 4 pi. That's better. So it's going to be 4 pi minus 8, because you should never get a negative number. That's how I knew I did something wrong. You should never get a negative number for your area. So now we're typing in 4 pi minus 8. So the area of that shaded sector is 4.57 meters squared.